Hello there and welcome back to The Sleep Science, the kind of corner on the internet where cosmic awe and bedtime calm collide. Tonight, you're lying there, maybe half tucked under your blanket, and out there, far beyond the hum of your fan and the glow of your phone screen, the James Webb Space Telescope is floating in the void, staring at light that left its galaxies before our planet even cooled. Imagine that. Photons older than the oceans, older than bones, older than the word old itself, slipping into a gold-mirrored eye and finding their way to you. You probably won't survive this, in the existential sense anyway. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, drop a comment below with your location and your local time. I always love seeing where in the universe you're listening from. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You're drifting above the black silence of space, looking down at a folded machine the size of a tennis court. Its sunshield gleams like 5 layers of silver silk, trembling slightly as sunlight brushes past. Below you hangs Earth, half blue, half shadow, and beyond that, darkness. The James Webb Space Telescope sits out here, a perfect compromise between human ambition and cosmic humility. It doesn't blink, doesn't speak, just opens its golden eyes and lets the oldest light pour in. Those hexagonal mirrors, 18 of them, beryllium-coated in vaporized gold, each catch whispers from the dawn of time. You hover close enough to see your reflection stretch across one panel, warped and scattered into 1,000 golden ripples. Webb's infrared sensors are tuned not for brightness, but for ancient warmth, the faint red shift of galaxies speeding away as the universe expands. What it sees is not the present, but a fossilized glow of everything that has ever been. You imagine the journey of one photon, born in the heart of a newborn star 13.5 billion years ago, flung into the endless dark, dodging nebulae, weaving through gravity wells, finally kissing Webb's detector like a traveller arriving home. That single photon carries history, the universe's first whisper after the Big Bang. Astronomers call this looking back in time, but it's not a metaphor, it's literal. The further you look, the older the light. Webb is, in essence, a time machine built from math, gold, and patience. A mainstream fact to ground you. The James Webb Space Telescope launched on December 25, 2021. A Christmas morning gift to everyone who's ever looked up and wondered. It took nearly a month to coast to its post at the L2 Lagrange point, 1.5 million kilometers away. There, Earth and the Sun's gravity tug just right so that Webb can orbit quietly, shielded from light and heat. Its mirrors unfolded one by one like origami in zero gravity, a ballet of precision that had engineers sweating bullets. Miss one command, and $10 billion of dream could have frozen into useless metal. And here's a fun fringe tidbit. Before launch, NASA engineers tested the telescope's deployment sequence in a giant cryogenic chamber once used for Apollo missions. They nicknamed it Chamber A, and rumour has it some of them left little trinkets, tiny figurines and handwritten notes inside the structure, tucked into corners where no one would find them for decades. Future scientists might one day stumble on those tokens and wonder if they were messages or offerings to the cosmic gods of calibration. You hover now, watching Webb's gold mirrors tilt toward a patch of black sky. The silence feels eternal. Then, faintly, images begin to appear on your mind screen, smudges of light so distant they predate galaxies like the Milky Way. Some look like spiral swirls already, too complex for their age. Historians still argue whether these early cosmic structures formed through normal physics, or if Webb has uncovered a flaw in our understanding of cosmic evolution. It's like walking into a museum expecting cave paintings and finding a fully furnished penthouse. As your mind floats deeper into this golden gaze, you can almost hear the hum of photons striking the detectors. They arrive one by one, like raindrops on an invisible window, each drop a record of something that happened before the first dinosaurs, before the first atoms of your body were forged. There's something heartbreakingly small about being human in this context. Yet paradoxically, Webb's discoveries make you feel part of it all, because you are. The iron in your blood, the calcium in your bones, the oxygen in your breath, they all once glowed in stars that Webb now observes at their birth. You shift slightly under your blanket, feeling the weight of cosmic time pressing against your eyelids. Somewhere out there, light from the first galaxies is still on its way. It will take another billion years to reach us, maybe longer, depending on how fast the universe continues to stretch. By then, humanity might be gone, or we might have built telescopes on the dark side of the moon, peering even farther back. For now, though, it's just you, Webb, and the soundless conversation between a human mind and the cosmos. There's a funny comfort in knowing that while we spend our days worrying about emails, traffic, and coffee temperatures, the universe keeps calmly unfolding, following laws that haven't changed since its birth. Webb doesn't care about deadlines, it just listens to the light. Maybe that's the real ASMR of astronomy, the slow, methodical hum of eternity doing its thing while we try to make sense of it. You breathe out, long and steady, and the black sky ripples with faint red light. The journey has begun, and the telescope, your golden time traveller, has already seen things you can hardly imagine. The first galaxies wait beyond the next curve of darkness, and soon you'll follow Webb even deeper, to places where light itself was young. You're still hovering beside the great golden eye, its honeycomb mirrors catching the faintest glow of history. The James Webb Space Telescope looks delicate from here, like some cosmic flower opening toward eternity. But the engineering behind it is anything but fragile. Every mirror is a triumph of precision, shaped to within a fraction of a wavelength of light. You could stack a human hair across its surface, and the deviation would be smaller than a single molecule. Each panel moves on microscopic actuators, tiny motors that shift the mirrors by mere nanometers to focus perfectly on light that's travelled across eons. You could say Webb is less a telescope and more an instrument of cosmic archaeology, brushing the dust off the universe's very first fossils. From your vantage point, the mirrors look almost liquid, shimmering gold against a backdrop of nothing. They're made of beryllium, chosen because it stays rigid in the freezing temperatures of deep space, where the telescope operates at about 40 Kelvin. That's minus 233 degrees Celsius, or, in human terms, colder than your ex's last text. The gold coating, a layer thinner than a human red blood cell, isn't just for show. It reflects infrared light with ruthless efficiency, and that's the key. Infrared light is what time does to starlight. It stretches it, reddens it, ages it. What was once a bright blue newborn galaxy becomes a faint ember by the time it reaches Webb's sensors. A mainstream historical fact slides into your mind. The very idea of an infrared space telescope this large began in the 1990s, long before the technology existed to make it possible. NASA originally called it the Next Generation Space Telescope, which sounds like a sci-fi spin-off rather than a $10 billion reality. It took more than 20 years of design, testing, budget battles, and political near-death experiences before the thing finally launched. In that time, some of its original engineers retired, some passed away, and others watched their own children join the mission they'd started. Webb isn't just a machine, it's a generation's promise fulfilled. Now picture this. Deep inside Webb's body lies a small sacred space where light meets detectors made of mercury-cadmium telluride, materials so sensitive that even a single stray photon could ruin an exposure. Those detectors are like the telescope's retinas, seeing not colour the way our eyes do, but heat, ancient heat. Each faint signal is then translated into data, sent in tight, encoded bursts to Earth through a radio dish no larger than a steering wheel. Somewhere in a control room back home, that stream of numbers becomes an image, a mosaic of the deep past rendered pixel by pixel. Here's a quirky fringe tidbit for you. During testing, engineers joked that Webb's mirrors were so finely tuned they could, in theory, detect the warmth of a bumblebee on the moon. While that's obviously hyperbole and a little adorable, it's not far from the truth. Its sensitivity is absurd. It can detect heat differences smaller than 1/10,000th of a degree. That's like noticing the faint warmth of a candle a million miles away. In that sense, Webb is both poet and spy, capturing whispers so faint that the cosmos itself seems to blush under its gaze. You drift closer to the centre of the mirror, watching faint lines of starlight reflect inward, converging at an invisible point. The telescope's focus isn't fixed. It adjusts with a patience only machines can possess. Each alignment takes days, each calibration checked and rechecked until the images sharpen. Scientists on Earth stare at screens showing star patterns that look like Rorschach blurs, tweaking them one actuator at a time. A star becomes a point, then a perfect dot, and suddenly the mirror is awake, aligned to see time itself. Historians still argue whether Webb's mirror design was inspired more by art or necessity. Some say the hexagons echo nature's efficiency, the shape of honeycombs, basalt columns, and carbon molecules. Others believe the shape was chosen purely for packing density and engineering stability. Either way, it's beautiful in a way most machines never get to be. It's as though the universe demanded a mirror shaped like its own mathematics. You imagine floating closer, running your gloved fingers just above the surface, careful not to touch. At this temperature, any human warmth would boil off in a puff of vapor. But the feeling you get is unmistakable. Reverence. You're looking at something built by human hands to reach beyond human limits. Every reflection here carries the fingerprints of thousands of people who dreamed that curiosity itself was worth $10 billion. Now you look into the mirrors again, but this time you see more than just stars. You see your own face distorted and multiplied. A reminder that every time Webb looks outward, it's also looking inward. That's the quiet paradox of space exploration. The farther we peer into the universe, the more we find pieces of ourselves scattered among the stars. You drift back, letting the telescope fill your view like a golden lotus in a black pond. Its panels glow faintly from distant sunlight, its structure humming with quiet energy. A thought slips in. This isn't just a camera. It's a time traveler sculpted by physics, art, and audacity. The mirror that sees time isn't just watching the universe. It's listening to its own reflection in the void. A soft chuckle escapes you as you realize something. The telescope never blinks, never sleeps, never complains about its Wi-Fi. It just keeps gazing deeper. Maybe that's what you envy most, the calm patience of something built to look, and only to look. While the rest of us flail through minutes and deadlines, Webb measures moments in millions of years. Out there, light continues to pour in, some from galaxies older than the imagination, some from stars just now forming. And as you float above this mechanical miracle, the hum of the cosmos feels almost musical. The gold mirror gleams like a lullaby for the universe, a shimmering ear pressed against the fabric of time itself. You drift farther from the glittering mirror now, letting the telescope shrink into the vastness. From a distance, the James Webb Space Telescope looks like a strange insect unfolding its wings, a golden body balanced delicately on a silver sail. Beneath that sail, unseen from most camera angles, hides one of the most ingenious pieces of orbital choreography ever attempted. Webb's perch at the L2 Lagrange point. It's not just hanging in space, it's balancing, dancing on invisible gravitational strings pulled tight between Earth and the Sun. You feel yourself swaying there too, caught in the same silent equilibrium, weightless and watching. If you were to measure, you'd find Webb about 1.5 million kilometers away, far beyond the reach of any astronaut's repair mission, far from the comforting magnetosphere of Earth. At that distance, sunlight doesn't fade so much as it stabilizes. Earth and the Sun always sit on the same side of the telescope, letting Webb's massive sunshield block both their glare and their heat. It's like sitting forever in twilight, the cosmic equivalent of camping under an endless sunset. The cold on the dark side is intense enough to freeze almost anything solid, but that's exactly what Webb needs to see the faint warmth of the ancient universe. A historical fact hums in your memory. The idea of Lagrange points dates back to the 18th century, when a mathematician named Joseph Louis Lagrange figured out that, under certain conditions, gravity could create pockets of stability in space. It's a wild concept. Gravity, usually the universe's great troublemaker, here becomes a kind of gentle anchor. These points are where the push and pull between two massive bodies cancel out just enough for an object to hover. There are 5 of them around the Earth-Sun system, like tiny gravitational eddies. The second one, L2, is where Webb now lives, perpetually trailing Earth's orbit, moving around the Sun but always facing the same way. It's peaceful out here. Too peaceful, maybe. You realize that Webb's existence depends on a near-perfect balance of forces, a fraction of a miscalculation, a slight drift, and it could wander into sunlight, heat up, and blind itself forever. That's why small thrusters occasionally nudge it back into position, whispering puffs of propellant to keep it still. Imagine trying to keep a balloon perfectly centered between 2 fans in a hurricane. That's what Webb's navigation team does every day, from millions of kilometers away. You float below now, looking up at the famous sunshield. It's enormous, about the size of a tennis court, and made of 5 razor-thin layers of a material called capton. Each layer reflects heat away, and together they reduce the temperature difference between the sunlit and shaded sides by almost 300 degrees Celsius. It's a cosmic air conditioner, and it keeps Webb's instruments cool enough to see the faintest glows of infrared light. Engineers say if even one layer had snagged during deployment, the whole mission would have failed. There was no backup, no plan B, no space shuttle ride to patch it up. It either worked perfectly or not at all. And here's a quirky tidbit. When Webb first reached its position, the sunshield began cooling faster than expected, so much that some scientists worried it might overcool and cause the telescope's parts to contract unevenly. For a few tense days, engineers on Earth actually had to sunbathe the telescope, slightly rotating it to catch a bit more solar heat just to warm it up. Imagine that. Humanity's most advanced space telescope, wrapped in million-dollar insulation, needing a little cosmic tan. Historians still argue whether positioning Webb at L2 was an act of courage or madness. Some claim it was reckless to send a one-of-a-kind machine beyond repair range. Others see it as the purest expression of faith in engineering, that humans can build something so perfect it doesn't need fixing. Either way, Webb sits out here now, alone and eternal, like a monument to precision. You drift closer again, and for a moment you sense the quiet hum of the onboard systems. There's no real sound, of course, just the vibration of electrons, the whisper of circuits regulating temperature, gyroscopes adjusting orientation. You imagine it as a kind of heartbeat, steady and patient, pulsing once every few seconds. A pulse that says, "I'm still watching, I'm still here." Below the sunshield, the telescope's body is dark and angular, its antennas folded with mathematical neatness. A small gold dish, its high-gain antenna, points toward Earth. That's the telescope's voice speaking through space, sending raw data in laser-tight radio beams that take about 5 seconds to reach home. Down there, on the other side of that invisible line, whole teams of scientists wait for those signals, converting ones and zeros into images that will make the world gasp. You think about how strange it is, this cold, silent machine out here, and yet every time it blinks, the whole planet listens. From this vantage, Earth is a distant blue glow, and the sun a blinding white disk behind the layered silver sails. There's something deeply poetic about it. This telescope never sees the planet that made it. Webb always faces away, its gaze fixed on the deep past. It's like an artist who refuses to look back at their own canvas, forever focused on the masterpiece just out of reach. You close your eyes for a second and let that thought sink in. Maybe that's what makes this mission feel so human, the longing to look farther than we can go, to send a piece of ourselves into the unknown and hope it sees something beautiful. The Lagrange point isn't just a location, it's a symbol of balance, of existence caught perfectly between light and dark, past and future, home and infinity. If you listen hard enough, you can almost hear Webb breathing with the rhythm of the universe. Every adjustment, every calibration, every photon caught in its mirrors feels like a heartbeat echoing through time. Out here, where gravity and silence meet, the telescope waits, still, watching, dreaming. From the quiet shadow of the Lagrange point, you tilt your gaze toward the darkness Webb has been staring into for years now. It's not the kind of darkness you're used to. It's a depth so ancient that even silence feels old. And then, there it is. A faint smear of light, dim and delicate, stretched thin by time itself. That little smudge, Webb's instruments whisper, is a galaxy. But not just any galaxy. It's one that existed when the universe was still rubbing the sleep out of its cosmic eyes. You blink, trying to make sense of the distance. 13.5 billion years. That's not just far away. It's before away even had a meaning. You'd expect such a baby universe to look messy and half-formed, a cosmic daycare of glowing blobs and scattered dust. But that's not what Webb is showing. These galaxies look too bright, too organized, too mature. Spirals already forming, stars packed tight, light blazing far stronger than theory allows. The universe, it seems, was in a hurry to grow up. The discovery left astronomers blinking at their monitors, muttering things like, "That can't be right," and "Did we mess up the math?" But the data kept coming, and it all said the same thing. The early cosmos was busier, denser, and brighter than we ever imagined. A historical fact rolls through your memory. Before Webb, the Hubble Space Telescope could only peer about 13.2 billion years back. Close, but not close enough to see the true beginning. Hubble's best deep-field images showed galaxies forming about 400 million years after the Big Bang. Webb smashed that record almost immediately, capturing galaxies from just 200 million years after creation. That's like discovering a baby photo of the universe that no one thought existed. The first time the data came in, scientists double-checked the timestamps, convinced the instruments had mistaken a closer galaxy for an ancient one. But no, the redshift values told the truth. Like that old simply shouldn't be that bright. A fringe tidbit drifts up, whispered between the photons. Some astronomers half-jokingly dubbed these early galaxies impossible galaxies. Not because they don't exist, they clearly do, but because our current cosmological models can't explain them. One astrophysicist compared it to finding a full-grown adult where you expected an infant. It's as if the universe skipped its teenage years and jumped straight into adulthood. Memes circulated among the research community, little web cartoons holding a magnifying glass saying, "I think the universe cheated on its homework." Historians still argue whether Webb's early discoveries genuinely challenge the Big Bang model, or simply highlight flaws in our star formation equations. Some believe our understanding of how gas clouds collapse into stars might be off by a factor of 10. Others suggest that dust and dark matter play larger roles than expected, amplifying brightness and structure. There's even a fringe theory floating around, one that dares to whisper that cosmic time might not stretch as evenly as we think, that the early universe played by slightly different rules. Nothing's proven, of course, but Webb has a way of making even the most confident scientists second-guess their textbooks. You imagine floating beside one of these early galaxies. It doesn't look like the graceful spirals you know. It's dense and glowing, a storm of newborn stars packed so tightly they're practically elbowing each other. Massive blue suns blaze and die within a few million years, scattering heavy elements that will one day become planets, oceans, and lungs. Every sparkle you see is a miniature apocalypse, supernova after supernova painting the cosmos with new materials. You're watching chemistry itself being invented. It's oddly comforting, knowing that all the chaos that once raged out here eventually cooled into something calm enough to cradle thought. As you drift closer, you realize that Webb doesn't just take pretty pictures. It reads the light, breaking it into spectra, tiny fingerprints of color that reveal composition, temperature, and motion. Those jagged lines tell us that even these impossible galaxies already had elements like oxygen, carbon, and neon, things that shouldn't have existed so early. In theory, the first generation of stars should have been made almost entirely of hydrogen and helium, with heavier elements forming only after several star life cycles. But here they are, shining defiantly, saying, "We've been busy." The thought makes you grin. Maybe the universe was just more efficient than we gave it credit for. Maybe it didn't need billions of years to build complexity. Maybe it was impatient. You can almost hear the cosmos chuckle at our surprise. It's a quiet kind of joke. We thought we understood creation, and then a golden telescope told us, "You're late to the story." Down on Earth, the scientific community buzzed for months. Papers flooded journals, headlines screamed, "Webb breaks the universe," and public fascination reignited like a starburst. Every new image felt like a postcard from the beginning of time. People cried watching them, not because they understood the data, but because they felt for the first time that they were witnessing the dawn. You can't help but feel a similar pull now. These galaxies, tiny red-shifted specks glowing softly against black, aren't just objects. They're memories. Each one holds the echo of an explosion that eventually led to you lying here, breathing, listening, wondering. Every atom in your body has travelled a path through this same ancient light. You are, quite literally, made of the stardust Webb has rediscovered. You close your eyes and imagine that glow, billions of years old, brushing against your skin like warm static. Somewhere, across impossible distances, more light is still on its way, bringing more surprises, more paradoxes, more evidence that the universe enjoys keeping secrets. Webb just happens to be patient enough to catch it in the act. You float in that cosmic dark, the newborn galaxies still glittering behind your eyelids, when another layer of realization settles over you. Those bright, early clusters of light are not just discoveries, they're arguments. You can almost hear the low murmur of astronomers across the planet, still debating what those images truly mean. The so-called cosmic dawn, that first few 100 million years after the Big Bang, is suddenly less like a simple chapter and more like a mystery novel with missing pages. The James Webb Space Telescope hasn't just shown us what happened, it's shown us how much we still don't know. Down on Earth, academic conferences turned into polite shouting matches. One side insists that the data must be misleading, that the galaxies only appear mature because dust and distance distort their light. Another camp argues that, no, the universe itself may have built stars faster than our equations predict. It's like finding skyscrapers in the Stone Age, one researcher said on live television. Somewhere between those two extremes lies the truth, but at the moment that truth is blurred like a half-focused star. A mainstream historical fact surfaces in your drifting mind. The phrase cosmic dawn was coined decades before Webb ever launched, by astronomer George Smoot, the same scientist who helped map the faint microwave afterglow of the Big Bang using the COBE satellite in 1992. Back then, the dawn was just a theoretical window, invisible to telescopes. Hubble glimpsed the faintest outline of it, but Webb has torn the veil completely, flooding that once hypothetical era with detail. What was imagination is now image. Still, historians of science can't help but smile at the irony. Humanity finally built a machine powerful enough to peer back to its own cosmic birth, only to realise the story might be out of order. Historians still argue whether this represents a paradigm shift, the kind that rewrites textbooks, or simply a recalibration, the kind that fine-tunes a blurry photo. But that uncertainty, that restless curiosity, is what drives every discovery forward. You picture a team of scientists sitting around a conference table, coffee cups cold, eyes red from staring at data. One slides a new spectrum printout across the table. "See that?" she says, tapping a line of peaks. "It's hydrogen, yes, but also oxygen." The others lean in, whispering, "That can't be right." But it is. The spectrum doesn't lie. The universe, only 300 million years old, already contained the seeds of complexity. The room fills with that electric mix of disbelief and joy, the same feeling you get when the universe winks and says, "You weren't expecting that, were you?" A quirky tidbit rises like a bubble through the silence. Somewhere on social media, enthusiasts started nicknaming this debate the Great Cosmic Dawn Drama. Memes flooded Twitter, Webb holding a magnifying glass over the Big Bang, or a cartoon Earth sweating while rewriting physics equations. It's strange, isn't it? A $10 billion space telescope becomes not only a scientific marvel, but also an internet personality. The universe has gone viral, and you can almost hear it sigh, amused. You float closer to one of those early galaxies, this time focusing on the faint reddish haze surrounding it. That haze is not just light, it's evidence of ionization beginning to stir, the process that would clear the cosmic fog and let the first stars shine freely. But for now, the debate down below keeps swirling. Was the cosmic dawn a slow sunrise, stretching over hundreds of millions of years, or was it a flash flood of starlight that brightened the universe almost overnight? Nobody knows yet. Some computer models predict a gentle ramp-up. Webb's data hints at a cosmic light switch flipped too fast. You can't help but laugh softly to yourself. Scientists arguing over how fast the universe turned the lights on sounds oddly human. The universe, you suspect, doesn't care how neatly we file its history. It just is. Still, those arguments matter. Every disagreement pushes understanding a little further, sharpens focus, forces minds to question even the constants they once swore were unchangeable. You remember reading that early after the images were released, one cosmologist said, "We've built a time machine and it's showing us a plot twist." That line stuck with you because it feels true. You can feel that twist now, floating here in the dark, surrounded by ancient light. The debate itself becomes part of the discovery, a cosmic echo of humanity's endless habit of arguing with itself in pursuit of clarity. Historians still argue whether Galileo ever truly muttered, "and yet it moves," after being forced to recant his heliocentric model. But if he had lived to see these Webb images, you think he might have whispered something similar, and yet it shines. Because no matter how much we argue about data interpretation, those galaxies remain. They exist. They glow. Their light took billions of years to prove that curiosity was worth it. You shift in the cosmic stillness, imagining you could reach out and hold that light between your palms. It trembles there, older than the Milky Way, humming softly with secrets. Somewhere back on Earth, In labs and classrooms, the debate continues. Voices overlapping, equations scribbled, hypotheses revised. But here in the void, the argument feels almost irrelevant. The galaxies don't care who's right. They just burn. You smile at that thought. Maybe that's the true heart of the cosmic dawn debate. Not the data, not the models, but the reminder that discovery is never clean, never quiet. It's messy and human and luminous, just like the stars we're trying to understand. You linger near that patch of newborn light, feeling the echo of debate still thrumming through it, and your attention drifts to what the Webb telescope truly reveals beyond structure and brightness, the chemistry of existence itself. You follow one of those galaxies closer until its glow fills your vision. Webb doesn't just show the shape of things, it listens to their stories in colour. Through its spectrographs, every shade of red, orange and infrared tells a secret, what the universe was made of at that exact moment. You watch the light split into delicate ribbons of wavelength, each line a confession from an atom that burned billions of years ago. When those first spectral results came down to Earth, they shocked the world again. Inside those impossible galaxies, Webb detected traces of heavy elements, carbon, oxygen, even iron, where there should have been only hydrogen and helium. For a universe that was supposed to be in its chemical infancy, this was like finding a complex symphony when the instruments were still being tuned. A mainstream historical fact flows through your thoughts. It was the 1950s when scientists first confirmed that all heavy elements are forged in stars through a process called stellar nucleosynthesis. Before that, no one really knew where the carbon in your lungs or the calcium in your bones came from. Stars, it turns out, are the universe's factories, and Webb has just shown that those factories opened much earlier than expected. You drift through the dark following the faint glow of one of those early star nurseries. Inside, the gas is thick with dust and radiation, chaotic but strangely rhythmic, like a slow, cosmic heartbeat. You can almost hear the whisper of new atoms colliding, merging and transforming. Somewhere within that storm, the first traces of metals form, not in the industrial sense, but in the cosmic one. Astronomers call everything heavier than helium a metal. It's oddly charming that to the universe, oxygen and iron are in the same category. A hydrogen atom might roll its eyes and say, "You're all heavyweights to me." A fringe tidbit comes to mind. One of Webb's early findings suggested the presence of silicates, yes, the same type of compounds found in sand, floating in interstellar dust barely 400 million years after the Big Bang. That means, quite literally, the building blocks of beaches existed before the first galaxies fully formed. Somewhere, long before any ocean lapped ashore, space was already making sand. That thought is strangely grounding, human and cosmic at once. You shift your gaze toward a cluster of newborn stars flaring within a gas cloud. They form in violent bursts, collapsing under their own gravity, igniting nuclear fusion in their cores. Each one shines for only a few million years, dying young and spectacularly. Their deaths scatter heavier elements into the surrounding space, seeding new generations of stars and planets. You can almost see the cycle unfolding: birth, death, renewal, all written in glowing filaments of dust. Webb watches it happen and translates it into data, revealing not just what the universe looked like, but what it smelled like in elemental terms: carbon, nitrogen, oxygen, the perfume of creation. Historians still argue whether Webb's chemical findings prove that star formation was simply more efficient in the early universe, or if we've underestimated how quickly nuclear fusion could enrich space. Some think dark matter played a hidden role, catalyzing gas collapse in ways we haven't modelled yet. Others whisper about cosmic variance, the idea that perhaps the patch of sky Webb happens to observe is a special region, unusually dense with material. The debate burns on, but the telescope doesn't take sides. It just keeps collecting light, one photon at a time, like a librarian archiving the autobiography of the cosmos. You move closer to one of those spectral graphs now, floating amid lines of colour that look almost musical. Each spike corresponds to an element. Oxygen hums in green, carbon thrums in red, iron whispers in deep infrared. You imagine a cosmic orchestra tuning itself. Every new line Webb records adds another instrument, another layer of harmony. Somewhere, perhaps billions of light years away, another civilization could be watching the same performance, hearing the same chords in their own wavelengths. Maybe they're also wondering what their atoms used to be. You think about how everything you are, all your memories, fears, favourite songs, was once part of this chemical experiment. The same carbon web just detected was forged in a star that burned out long before our galaxy existed. The oxygen in your next breath might have once belonged to a supernova in a forgotten corner of the universe. It's almost funny that we call these discoveries shocking, when in truth, they're reminders of the most intimate connection imaginable. You're made of this. Every molecule of you is cosmic inheritance. A quiet laugh bubbles up as you realise that Webb has basically turned into the universe's genealogist. Instead of tracing family trees through DNA, it's tracing the ancestry of atoms through light. If starlight had a last name, Webb would be the one checking the cosmic birth records. You drift back slightly, watching another galaxy's spectrum flare across the screen. It's beautiful, yes, but it's also data. Cold numbers that scientists will spend decades decoding. Somewhere in that data may lie clues to how quickly matter assembled, how early stars died, how black holes began to stir. The chemistry of ancient starlight isn't just science, it's storytelling on a cosmic scale. You breathe slowly, eyes half closed, letting that realization settle. The early universe was never empty. It was a cauldron, bubbling with potential, and Webb, golden and patient, has become our window into that alchemy. It's as if the telescope has caught the universe mid-sentence, and for the first time we're starting to understand the language. You drift onward through the tapestry of newborn light, following those threads of heavy elements deeper into the ancient dark. Somewhere ahead, the glow changes, less structured, more primal. Here lies a mystery that's haunted astronomers for generations, the elusive population 3 stars, the very first stars to ever exist. They're theoretical, almost mythical, like the cosmic equivalent of the missing link. No telescope has ever seen them directly, not even Webb. But their fingerprints, those subtle chemical absences and spectral clues, linger like ghost handwriting across the universe's earliest light. You move toward that silence where they should be, wondering if you're about to glimpse creation in its rawest form. Population 3 stars, the story goes, were giants, hundreds of times the mass of our sun, burning so hot and so bright they lived fast and died young, scattering the first metals into the cosmic sea. These were the original fusion engines born from pure hydrogen and helium left over from the Big Bang. Imagine an era with no oxygen to breathe, no carbon to form life, no iron for blood or planets. Just vast transparent gas clouds collapsing under gravity's pull, igniting into blue-white furnaces that would live only a few million years before tearing themselves apart. You hover within one of those clouds now, seeing nothing but ultraviolet fury. It's so intense it feels like standing too close to a divine forge. A mainstream historical fact flickers into view. It was in the 1970s when astrophysicists first theorized these primordial stars. Without heavy elements to cool their surrounding gas, they concluded these first suns must have been enormous, perhaps 1,000 times the mass of ours. Computer simulations decades later refined the prediction, but never captured direct proof. Every telescope before Webb lacked the sensitivity to peer back that far. Webb, with its infrared eyes, was designed specifically to find their echoes, to catch the faint afterglow of a universe before complexity. Yet, even now, they remain hidden. The universe, it seems, guards its first secret tightly. You lean closer, watching Webb's detectors translate another deep field exposure. Faint red smudges appear. Possible candidates, maybe clusters of stars so ancient they could contain a few of those elusive giants. Astronomers on Earth hold their breath. The data comes through in waves of numbers, a digital heartbeat from 13 billion years ago. The analysis begins, the arguments follow. Historians still argue whether Webb has actually caught glimpses of Population 3's aftermath, or if we're simply mistaking early, metal-poor galaxies for something older. The debate turns poetic. Did Webb just photograph the universe's first generation, or its grandchildren playing in the ruins? A quirky tidbit drifts through cosmic memory. One research team nicknamed these hypothetical stars the gods that died too fast. In a conference presentation, a physicist even played a snippet of heavy metal guitar under the slide that read Population 3, Born to Burn. The room erupted in laughter. After all, science needs a sense of humour when staring into eternity. The phrase stuck. Now, in online forums, you'll find fans calling Webb the God Hunter. The telescope probably doesn't mind. It's too busy chasing light that's older than myth. You watch the simulated death of one of these primordial suns in your mind's eye. It doesn't fade quietly. It collapses inward until even light hesitates, then erupts outward in a blast 1 billion times brighter than any supernova we know today. That explosion seeds the surrounding void with new elements: carbon, oxygen, iron, the first ingredients for everything familiar. Each detonation is like punctuation in the universe's first sentence. Without those cataclysms, there would be no chemistry, no planets, no coffee, no you. The thought makes you smile, half amused, half reverent. The first stars died so we could one day argue about them on the internet. You imagine being Webb at that moment, blind yet all-seeing, gathering whispers of those deaths through faint distortions in spectral lines. Somewhere in those patterns hides the proof, but interpretation is a delicate art. A slight calibration error could turn a discovery into an illusion. Yet scientists keep searching, building catalogue after catalogue of candidate galaxies, each one labelled with redshift values and cautious optimism. In the same way, you realise every human search for meaning is a kind of spectroscopy. We all study the faint spectra of our own beginnings. Historians still argue whether the universe's first stars formed individually or in clusters. Some models suggest a single massive star dominating each gas cloud. Others imagine swarms of mid-sized suns forming together, shaping one another's destinies through gravity. Webb's data might someday answer that, but for now the discussion remains as open as the cosmos itself. There's something comforting about that uncertainty. It means there are still frontiers left to explore. You drift back slightly, gazing across the golden panels of the telescope, catching light from so far away it's practically time itself. Somewhere out there, perhaps just beyond Webb's reach, those first stars still shine, though their light is stretched, faded, softened by expansion. The photons that once burst from their cores now pass quietly through the telescope's sensors, like ghosts telling stories in code. And down below, millions of kilometers away, humans translate that ghost light into meaning, trying to resurrect stars that have been dead for 13 billion years. A thought curls around you. Maybe that's what makes this pursuit so beautiful. We are a species that builds machines to remember what the universe has forgotten. Webb isn't just looking for ancient light. It's searching for lost memory. Every pixel it captures is a resurrection, every spectrum a whisper from creation's first moment of courage. You watch the telescope tilt, the mirrors catch a faint red shimmer, and for a second, you swear you see the flash of something vast and blue. Too bright, too brief. Perhaps a population 3-star finally saying hello before fading again into myth. You exhale, the darkness pulsing gently around you, and the thought comes quietly. We may never see those first stars clearly, but knowing they existed is enough. Their ashes are everywhere, in planets, oceans, veins, and dreams, and if Webb never finds them, that's fine. They've already found us. You hover in silence, the ghosts of those vanished titans still glowing faintly behind you, and your focus turns toward the strange shadows flickering at the heart of some of those early galaxies. The light curves oddly there, stretched and twisted as though something invisible is swallowing part of it. At first, you think it's a distortion, maybe a lensing artifact, but Webb's data insists otherwise. The telescope isn't just capturing the universe's first stars, it's also witnessing the universe's first monsters. These are the black holes that should not exist yet. Vast, hungry, ancient, and somehow already enormous when the cosmos was still an infant. You feel the pull even from here, the faint, slow tug of gravity so intense that not even light can argue with it. A mainstream historical fact anchors the awe. The first confirmed black hole detection came in 1964, when astronomers studying the star Cygnus X1 realized it was orbiting an invisible companion with the mass of 15 suns. That discovery alone changed the way we saw the cosmos. But what Webb is finding out here makes Cygnus X1 look like a campfire compared to a volcano. These early black holes aren't just massive, they're supermassive, millions or even billions of times the sun's mass, existing mere hundreds of millions of years after the Big Bang. According to current physics, there simply shouldn't have been enough time for them to grow so big. And yet, there they are, shining through the galaxies they devour. You watch one now, or rather you watch what surrounds it. No telescope can see a black hole directly, Not even Webb, but you can see its signature. A blazing quasar, a halo of light from matter spinning at nearly the speed of light as it spirals inward. It's terrifying and mesmerizing, like watching a whirlpool made of stars. The light flickers in chaotic rhythm, high-energy radiation pulsing as magnetic fields twist and snap. You can't help but think of it as breathing, slow and monstrous, the cosmos inhaling its own creation. A fringe tidbit surfaces, a rumour from one of Webb's first analysis groups. They noticed one quasar's light curve seemed to pulse in a repeating pattern, almost like a heartbeat every few days. No one's sure why. Maybe it's a binary black hole system, two beasts orbiting each other in a gravitational dance. Or maybe it's an illusion, a coincidence in the data. Still, the team jokingly dubbed it the cosmic metronome, and even composed a short musical track based on its light variations. Somewhere there's a Spotify playlist of black hole beats. Historians still argue whether these early black holes were born small and grew absurdly fast, or if they somehow started big, born from direct collapse, skipping the usual stages of stellar death. Each theory brings its own paradox. If they grew fast, then something must have fueled them at impossible rates. If they started big, we have to rewrite what we know about how matter condenses. Either way, Webb's findings are poking holes in the tidy timeline of cosmic evolution. The universe, once again, refuses to follow our rules. You drift closer to the luminous swirl of a quasar, watching its light bend around the invisible center. You can almost feel the curvature of space itself, a sensation like leaning too close to the edge of a dream. The gas around it glows brighter than an entire galaxy, yet the center remains perfectly black, perfectly silent. You can't help but think of it as the ultimate contradiction, an object that exists only by erasing itself. It's almost poetic if poetry could devour everything it describes. The radiation from that whirlpool hits you like a wave of colorless heat. Webb captures it not as visible light, but as infrared signatures, faint ripples of warmth that tell stories of matter being torn apart atom by atom. Those signals travel across billions of years and land delicately on Webb's detectors, where they become numbers, then images, then awe. You can picture the scientists seeing those readings for the first time, their brows furrowed, their voices low. How could it already be that massive, someone asks. Another shakes their head. It shouldn't exist yet, and yet it does. The black hole's mass warps the space around it so completely that distant galaxies behind it appear stretched into luminous arcs, a phenomenon called gravitational lensing. Webb uses those distortions to map the invisible geometry of space-time itself. Each warped image becomes a clue to the unseen. You marvel at the irony. We only know these monsters exist because they bend reality enough for light to betray them. The universe hides its darkness behind light, and Webb catches it in the act. A small laugh escapes you when you remember that for centuries black holes were considered fantasy. Even Einstein doubted they could form naturally. He called them mathematical curiosities, elegant but unrealistic. Historians still argue whether he would have changed his mind had he lived to see Webb's images, bright quasars blazing where only primordial fog should be. Maybe he would have smiled that quiet Einstein smile and said, "The cosmos is cleverer than we are." You drift back a little, watching the quasar fade into darkness. Around it, new stars continue to form, oblivious to the monster at their center. Maybe that's the strangest part. Destruction and creation intertwined, each feeding the other. Black holes don't just consume, their outbursts of energy actually trigger new star formation in surrounding regions. Every death in the cosmos seems to plant a seed for new life. You can't decide whether that's horrifying or beautiful, so you settle on both. Somewhere deep inside the telescope, photons from that ancient light strike sensors the size of fingernails. The signal travels through copper wires, then radio waves, then data streams, until it lands on screens back on Earth, our planet, a tiny blue speck analysing the universe's appetite for itself. You exhale softly, the sound lost to vacuum, and feel something profound. Maybe the universe's first monsters weren't mistakes or anomalies. Maybe they were necessary, anchors in the chaos, gravity's way of shaping everything that came after. You turn slowly, the light of that quasar fading into a crimson whisper, and realise the thought that follows is as vast as the void itself. Even the darkness had to learn how to shine. The echo of those early black holes still hums in your chest as you glide forward into softer light. The glare of the quasars fades, and what replaces it is stranger, an endless ocean of haze stretching across the cosmos. It glows faintly, like fog backlit by sunrise. You're drifting through the era astronomers call reionization, the moment when the universe went from opaque to transparent. Before this, light couldn't travel freely. Every photon was trapped, scattered by clouds of neutral hydrogen that filled all space. The cosmos was, for hundreds of millions of years, a thick, glowing fog. But then the first stars and galaxies ignited, and their ultraviolet light began to tear those atoms apart, ionizing them, and the fog started to lift. You can almost feel the breath of that moment, when darkness gave way to clarity. A mainstream historical fact threads into the silence. The idea of cosmic reionization was first proposed in the late 1960s, when astronomers studying the quasar 3C 273 noticed peculiar absorption lines in its spectrum. Those lines hinted that somewhere between us and that distant quasar, clouds of neutral hydrogen still existed. It took decades of theory, observation, and more than one telescope's lifetime before scientists pieced together the story. After the Big Bang's initial fireball faded, the universe cooled into darkness until those first lights flickered on, burning holes through the mist. Webb, with its unmatched infrared sensitivity, has finally given us the clearest glimpse of that transformation. From your perspective here, it feels less like data and more like revelation. You float inside the haze and it glows around you, soft, pinkish, full of movement. You can sense the ultraviolet photons slicing through, carving paths like lightning through fog. The process is violent and tender at once, billions of tiny explosions of enlightenment spreading across the cosmos. The metaphor writes itself, the universe waking up. A quirky tidbit drifts up. Some scientists describe this transition as the universe switching on the lights, but one NASA engineer jokingly called it the first cosmic group chat, because once light could travel freely, galaxies could finally talk to one another through radiation and gravity. There's something wonderfully human about that. A universe gossiping across billions of light years, finally able to share its stories. You imagine it whispering, "Did you see that supernova over there? Wild night." Historians still argue whether reionization happened slowly, like dawn spreading across a sky, or in sudden bursts, patchy and chaotic, each galaxy clearing its own little bubble of transparency. Webb's observations are beginning to settle that debate, just barely. Its deep field surveys show pockets of clarity surrounded by dense fog, like stars shining through misted glass. Some scientists think reionization finished about 1 billion years after the Big Bang. Others suspect it stretched longer. Webb's data, as always, refuses to give easy answers. The telescope records the light, and humanity squabbles lovingly over interpretation. You glide closer to a region where the fog thins into transparent space. Beyond it, galaxies glow in clusters, bright and confident. Behind you, the haze still flickers, a reminder of how recently the cosmos was blind. You think about how much that mirrors us. For most of human history, the night sky was mystery and myth. We looked up and filled the gaps with gods, dragons, and heroes. Only recently, mere centuries ago, did we start to see the truth, to reionize our own understanding. Maybe that's the secret symmetry of it all. The universe clears its fog just as we clear ours. The physics of it is beautiful in its simplicity. When ultraviolet light from the first stars struck neutral hydrogen atoms, it stripped away their electrons. Those electrons raced free, allowing light to finally pass through space unobstructed. The cosmos became transparent, and for the first time, starlight could travel billions of years unimpeded, some of it right into Webb's golden mirrors. Every image the telescope captures is made possible by that ancient moment of liberation. If reionization hadn't happened, we would never see anything at all. A small, amused thought crosses your mind. Somewhere out there, a photon that escaped during this transition might still be flying, untouched for 13 billion years, only to end its journey inside a metal box built by a species that didn't exist when it left. Imagine that, light older than every mountain, every memory, landing softly on a sensor designed to understand it. It's like an ancestor's voice finally reaching its descendants. Historians still argue whether quasars or galaxies contributed more to ionization. The evidence goes back and forth. Quasars, those ravenous black holes you just left behind, emit intense radiation that could ionize massive regions of space. But galaxies, though fainter, were far more numerous, their collective starlight possibly doing the heavier lifting. Webb's spectral surveys are trying to weigh those contributions, pixel by pixel, like a detective sorting fingerprints on the cosmic windowpane. You float above one such pocket of clarity now, watching the haze ripple like the surface of a sea. The boundaries between dark and light shimmer with motion. Stars within the newly cleared zones flare with colours Webb can barely capture. Crimson, amber, violet. Somewhere nearby, a quasar's outburst flashes like lightning, its ultraviolet wavefront carving a tunnel through the fog. You realise the universe wasn't silent in its awakening. It was full of noise, light, radiation, chaos. It must have been breathtakingly alive. You breathe in softly, knowing that you're inhaling atoms that once wandered through that ancient glow. The hydrogen in your body, the most abundant element in your cells, was forged before this transition, while the universe was still opaque. Every breath you take carries a trace of that ancient fog, a molecular memory of the time when light was still learning how to travel. And then you see it, the fog fading completely, replaced by the crystalline depth of open space. The galaxies beyond shimmer clearly for the first time, thousands of them packed into the void like glitter spilled across black velvet. The era of reionization ends, and the visible universe begins. You can almost hear a sigh ripple through existence, the sound of the cosmos stretching its newborn limbs. Somewhere, the James Webb Space Telescope captures that very image. The final clearing of the fog, the dawn fully risen. Back on Earth, scientists will translate it into colours the human eye can see. They'll call it data, but you know better. It's the universe remembering how to shine. You hover at the edge of that now transparent universe, marvelling at how light finally roams freely, when something beneath the surface of those newborn galaxies begins to tug at you, a slow, invisible rhythm that feels almost like gravity's heartbeat. The stars and gas swirl in recognisable patterns, too orderly for random chance, and you realise you're watching the scaffolding of everything take shape. What's holding it all together isn't visible matter at all. It's the shadow substance scientists call dark matter. You can't see it, can't touch it, but without it, the universe would be a scattered fog of lonely atoms. With it, galaxies spin, clusters form, and the cosmic web stretches like a luminous net across infinity. A mainstream historical fact glimmers in memory. It was 1933 when Swiss astronomer Fritz Zwicky first noticed that galaxies inside the Coma cluster were moving far too fast to be held together by the gravity of their visible stars. He coined the term dunkle Materie, dark matter, to describe whatever invisible mass must be anchoring them. Decades later, Vera Rubin's careful work on galaxy rotation curves confirmed the mystery. The outer stars of spiral galaxies weren't slowing down as expected. Something unseen was binding them in orbit. Those discoveries quietly revolutionized cosmology, but even now, nearly a century later, no one knows exactly what dark matter is. You drift through the void between galaxies and the view changes. The emptiness isn't truly empty. Faint outlines shimmer like threads of glass connecting distant clusters, an ethereal spiderweb made of gravity itself. Webb can't see dark matter directly, but it traces its effects through lensing, the way invisible mass bends light from objects behind it. Each warped arc in Webb's images is like a fingerprint of dark matter's presence. You follow one such distortion now, a curved smear of a galaxy stretched into a delicate crescent. It's beautiful in a quietly unsettling way, proof that the unseen outweighs the seen by a factor of about 5 to 1. A quirky tidbit comes to mind. Scientists once calculated that all the ordinary matter in stars, planets and dust adds up to only about 4.9% of the universe. Dark matter accounts for roughly 27%, and the rest, almost 70%, is something even stranger. Dark energy. The mysterious pressure that makes space itself expand faster over time. You chuckle softly. We live in a cosmos where 95% of reality is invisible, yet we still argue about the remaining 5 as if we own the place. Historians still argue whether dark matter actually exists, or whether it's just a sign that our understanding of gravity is incomplete. Modified gravity theories, MOND, TVs and their cousins, propose tweaks to Einstein's equations that could mimic dark matter's effects without needing unseen particles. The debate swings like a pendulum every few years, depending on the latest data. Webb's precise lensing maps are now fueling the next round of arguments. Some researchers claim its observations support dark matter halos wrapping around galaxies like invisible cocoons. Others insist the patterns could emerge naturally from revised gravitational physics. The universe, meanwhile, keeps spinning, utterly indifferent to whose math wins. You imagine drifting alongside one of those halos now. There's nothing to see, yet the sensation is unmistakable. A gentle pull from all directions, a gravitational whisper that tugs at the soul more than the body. If dark matter particles exist, they barely interact with normal atoms. Billions are likely passing through you this very moment, ghostly travellers that never leave a trace. One physicist once said, "We're swimming in a cosmic ocean and can't even feel the water." Out here, that metaphor feels literal. You move deeper into the filament of the cosmic web, where thousands of galaxies dangle like jewels along invisible strings. The pattern resembles neurons in a cosmic brain, each cluster a glowing synapse firing across unimaginable distances. You wonder if consciousness itself, on some grand scale, mirrors this structure. Maybe dark matter is the universe's connective tissue, the framework upon which luminous thoughts, stars, planets, life can form. It's a romantic notion, sure, but then again the cosmos has always been a little theatrical. A faint tremor runs through space, gravitational lensing at work again. Far behind this dark matter skeleton lies a more distant galaxy, its light warped into twin images by the invisible mass between you and it. Webb captures that distortion perfectly, allowing scientists to weigh the unseen by its effect on the visible. In a way, the telescope has become the universe's balance scale, measuring the weight of ghosts. You smile, thinking of Zwicky again, his gruff humour, his wild ideas. He once called his colleagues spherical bastards because he said, "They're bastards no matter how you look at them." You imagine him laughing from whatever corner of the afterlife scientists occupy, delighted that the mystery he stumbled upon still drives half the field mad with curiosity. And then the humour fades into awe. Without dark matter, galaxies would fly apart. Without those invisible halos, stars wouldn't cluster, planets wouldn't form, and you wouldn't be here, floating in wonder. The invisible has always been the foundation of the visible. It's almost a cosmic joke that the things we can't see, gravity, time, dark matter, love, are the ones that hold everything together. You glance back toward Webb, its golden mirrors reflecting the faint arcs of lensed galaxies. The telescope isn't built to solve the dark matter mystery, but every pixel it captures tightens the net of evidence around it. Somewhere in that data might be the first true clue, maybe a hint of particle interaction, maybe a statistical anomaly whispering a new law of physics. Humanity will spend decades decoding it, but for now, you let the mystery remain intact. The cosmic web stretches endlessly before you, glowing faintly against the black. You can almost hear it hum, a deep, resonant vibration, like a cello string plucked by gravity itself. That's the sound of structure forming, of invisible hands shaping the universe's bones. You realize you've never felt so small or so supported. Even when everything seems empty, something unseen is always holding you in place. You follow one of those faint cosmic filaments, tracing its glowing path through the dark until the galaxies begin to gather more densely around you. They don't sit quietly, they swirl, collide, merge. Here, the universe isn't static, it's alive with motion, sculpted by gravity's endless choreography. You watch as two young galaxies, barely a few 100 million years old, draw close, their halos of stars stretching toward each other like fingertips. At first, they pass by with just a gravitational handshake, but the pull is irresistible. Over the course of millions of years, they spiral inward, their gas clouds colliding, compressing, birthing new stars in a frenzied burst of light. You can almost feel the vibration of that union humming through space. The James Webb Space Telescope has captured scenes like this, galaxies colliding in the early universe, long before they were supposed to. According to old models, it should have taken billions of years for cosmic structures to grow large enough to merge on this scale. But Webb's images show tangled webs of interaction happening when the cosmos was still in its toddler years. It's like walking into a kindergarten and finding skyscrapers under construction. The telescope's infrared gaze reveals tidal tales, long, delicate streams of stars pulled apart by gravity's tug-of-war, forming patterns that look like silk ribbons twisting in slow motion. A mainstream historical fact flickers in your mind. The first galaxy merger ever identified was the antennae galaxies, observed in the 18th century by William Herschel. Those two colliding spirals, about 60 million light-years away, became the textbook example of what happens when gravity gets romantic. But Herschel could never have imagined seeing the same drama unfolding billions of years earlier, at the dawn of everything. Webb has now spotted protoclusters, primitive cityscapes of galaxies merging into massive structures, when the universe was less than 1 billion years old. A quirky tidbit floats by. Astronomers sometimes nickname these early mergers cosmic traffic jams. There's even a running joke in the astrophysics community that the universe doesn't obey the speed limit. It accelerates through development like an impatient driver late for work. During one of Webb's first deep field analyses, a researcher reportedly looked at a dense group of colliding galaxies and sighed. Well, that's the universe double parking again. It's a strange kind of humour, born from the sheer absurdity of watching entire galaxies bump into each other like celestial bumper cars. You drift between two merging clusters, each one glowing in shades of crimson and violet. The gravitational pull between them warps the space around you, stretching light into long arcs, another example of gravitational lensing, but this time created by the galaxies themselves. Gas clouds within them slam together, triggering waves of star formation that ripple outward like fireworks. You think about how every star born here will live for billions of years, orbiting within a new, larger galaxy forged by the chaos. Webb's instruments record the heat signatures of those infant stars, capturing light that began its journey before the Milky Way even existed. Historians still argue whether these early collisions happened because the universe was smaller and denser, so galaxies simply couldn't avoid one another, or because dark matter filaments funneled them together deliberately, shaping the first massive clusters. Either way, what you're watching now is the universe building its architecture. Each merger adds mass, momentum, and complexity, transforming scattered fragments into structures grand enough to seed the cosmic neighborhoods we see today. You imagine pressing your palm against one of those vast gas bridges connecting two colliding galaxies. It would feel like static and wind all at once, a stream of ionized hydrogen racing between worlds at hundreds of kilometers per second. Somewhere within that bridge, new suns are forming, glowing softly as they ignite. They don't know they're part of something violent. They just burn because that's what stars do. Creation, it seems, often hides inside destruction. The spectacle unfolds in silence. Stars tear apart, black holes merge, dust clouds scatter like glitter in the void. And Webb, ever patient, keeps watching. It's not just taking pictures, it's collecting evidence. Spectral fingerprints that reveal how fast these galaxies are moving, what elements their stars contain, and how gravity molds them. You realize this isn't chaos, it's choreography. Gravity doesn't destroy without reason. It's sculpting, shaping, merging energy into form. The cosmos is messy, yes, but it's also an artist. A soft laugh escapes you as you remember how humans often mirror this same pattern. Our collisions, our entanglements, our capacity to create beauty out of disorder. Maybe galaxies are just the universe's rehearsal for empathy, learning how to collide without coming undone. You drift through the space between them, a safe spectator to their luminous turmoil, and think of how many billions of future planets will spin out of the debris of this merger, each one carrying potential life, potential memory. Historians still argue whether Webb's discovery of these early galactic collisions means our models of cosmic timeline are wrong, or simply incomplete. If galaxies were forming and merging this early, it might imply that matter clumped faster than predicted, perhaps because of dark matter's influence or unknown physics. Every new image Webb sends home forces cosmologists to rewrite another line of their story, sharpening the picture while deepening the mystery. The telescope is not just revealing history, it's editing it in real time. You turn slowly, watching the two galaxies fuse completely. Their cores meet in a burst of ultraviolet fire, then calm as they settle into a new elliptical form. The chaos resolves into symmetry. From here, it looks almost peaceful. two once lonely wanderers becoming one. Light from their merger streams across the void, travelling for billions of years until it finds a mirror made of gold and beryllium, and through that mirror it finds you. You smile at the thought that somewhere, another civilization might be watching a similar collision from their own corner of space, feeling the same mix of awe and insignificance. Collisions are universal. They happen to stars, galaxies, people, ideas, and sometimes from the wreckage something entirely new begins to glow. The light from those galactic collisions fades into a softer, steadier glow as you drift onward. The violence gives way to serenity, spiral arms flattening, dust settling, stars orbiting in calm rhythm. Webb's mirrors now turn towards smaller, quieter lights, stars not unlike our sun, each one orbited by worlds too faint for the naked eye to see. After billions of years of cosmic construction, the universe has finally built something new: stability. The stage is set for the next act, one where matter doesn't just burn and collapse, it begins to organise, to experiment. This is where the search for exoplanets begins. You feel it before you see it, the subtle dimming of starlight, like a cosmic heartbeat skipping a beat every few days. That's the sign Webb has been waiting for, the passing shadow of a planet across its parent star. A mainstream historical fact slides into your thoughts. The first confirmed detection of an exoplanet orbiting a Sun-like star came in 1995. Swiss astronomers Michel Mayer and Didier Queloz announced they had found a world called 51 Pegasi b, a gas giant so close to its star that a year there lasts just 4 Earth days. It was the moment humanity realised our solar system wasn't unique. Since then, we've catalogued over 5,000 exoplanets using telescopes like Kepler and TESS. But Webb's mission is different. It doesn't just detect them, it dissects them. Its infrared spectrographs can read the light passing through an exoplanet's atmosphere, teasing out the chemical ingredients hidden within. It's the cosmic equivalent of sniffing the air of another world from across the galaxy. You imagine hovering near one of these distant stars. A small rocky planet crosses its face, casting a faint shadow that Webb detects from millions of kilometres away. The telescope's instruments split the starlight into a rainbow, analysing the way certain colours dim or brighten during the transit. In those subtle shifts lies a code: water vapour, carbon dioxide, methane, maybe even oxygen. You realise that Webb is doing something extraordinary. It's reading weather reports from worlds that orbit suns hundreds of light years away. A quirky tidbit glimmers in memory. One of Webb's first exoplanet spectra came from a gas giant called WASP-39b. When scientists saw the data, they noticed something unexpected. Clear signatures of carbon dioxide and sodium, the first definitive detection of CO2 in an exoplanet atmosphere. Someone on the team reportedly yelled, "We found climate," in the control room, half joking, half in awe. They weren't exaggerating. For the first time, humans were directly measuring the chemistry of another planet's sky. You drift closer to a different system now, one smaller and cooler. A dim red star burns at its centre, its light soft and rusty. Around it orbit several rocky planets. Webb's instruments have studied systems like this too. They remind you of home, but humbler, quieter, stripped of the glare of a yellow sun. The telescope's data shows one of them may have water vapour in its atmosphere. Another perhaps has clouds made of silicate dust, tiny grains of glass suspended in alien winds. You can almost taste the air, metallic, dry, sharp. Historians still argue whether Webb's exoplanet studies will ever lead to definitive evidence of life. The telescope isn't designed to take direct images of Earth-like worlds. It can only infer their nature through light analysis. Still, that hasn't stopped scientists from dreaming. Some think Webb's instruments might detect biosignatures, chemical imbalances like methane and oxygen coexisting, hinting at biological processes. Others caution that false positives are easy to mistake for miracles. Yet every new spectrum Webb captures adds another piece to the puzzle, narrowing the range of what's possible. You imagine the data streams flowing back to Earth, numbers that scientists translate into colours, shapes, and atmospheres. Each exoplanet is a probability, a question wrapped in radiation. You think about how strange it is that humans, a species still arguing about property lines on one small planet, are already analysing the skies of hundreds more. Maybe that's the real miracle, not what Webb finds, but that we dared to look. You turn your gaze toward one particularly intriguing world, a gas giant orbiting close to a dim orange star. Webb's sensors pick up faint traces of sulfur dioxide, likely produced by photochemical reactions in its upper atmosphere. In simpler terms, alien smog. You grin at the thought. Even in the vastness of space, pollution finds a way. Somewhere, a planetary scientist is thrilled to see that haze, proof that sunlight is sculpting chemistry far from home. A whisper of humour threads through your mind. The first time Webb detected water vapour on a distant world, social media lit up with jokes. "Breaking, universe confirms hydration," someone tweeted. But beneath the humour, there was awe. That water, those molecules, are the same kind that once condensed into Earth's oceans, the same hydrogen forged after the Big Bang, the same oxygen birthed in ancient stars. Webb wasn't just finding planets, it was finding reflections of us scattered through time. Historians still argue whether life in the universe is rare or inevitable. The Drake equation, that famous thought experiment from the 1960s, tried to quantify the odds, but it's always been more poetry than math. With Webb, those numbers are beginning to feel tangible. Each planet detected, each molecule measured, is a new verse in the cosmic song of probability. You realise that the telescope's search for exoplanets isn't just about finding neighbours, it's about answering the most human question imaginable: are we alone? You float for a moment longer, watching the faint orbits dance below. Somewhere, right now, Webb is capturing another transit, another whisper of starlight passing through an alien sky. Maybe it's a gas giant, maybe a rocky twin of Earth, maybe something entirely unknown. Whatever it is, the light from that moment will take years to reach home, where it will appear as a simple pattern of lines on a scientist's monitor. And yet, contained within it, is the promise of discovery. You exhale slowly, letting the thoughts settle. Webb isn't just looking outward, it's holding up a mirror, reflecting the fundamental human urge to find connection, even across the vacuum of space. In every exoplanet it studies, you can see a fragment of the same story, the universe learning to know itself. You drift toward one system that has captured the world's imagination more than any other, the one Webb's cameras have lingered on with almost human fascination. Its star glows faintly red, no brighter than a coal in the cosmic fireplace, and around it circle 7 small rocky worlds like pearls on a dark string. This is TRAPPIST-1, the quiet celebrity of the galaxy, a miniature solar system about 40 light-years away that has become the poster child for hope. When the telescope focuses here, it's not just collecting data, it's reading a love letter to possibility. A mainstream historical fact flickers through your memory. In 2017, astronomers using the TRAPPIST telescope in Chile announced that this small red dwarf star hosted 7 Earth-sized planets, 3 of which lay within the habitable zone where liquid water could exist. It was a headline heard across the planet, 7 potential Earths found. The Spitzer Space Telescope and later Hubble confirmed the findings, but it was James Webb that promised to go deeper, to peel away the atmospheres of these distant worlds layer by layer and search for the faintest scent of life. You imagine floating near the star now, TRAPPIST. One itself is tiny, barely the size of Jupiter, its light dim and coppery. Its planets are so close that all 7 could fit within the orbit of Mercury. You could stand on one world and see the next hanging huge in the sky, glowing like a bronze moon. The telescope's infrared sensors are tuned precisely for this kind of dim star, reading its warmth rather than its brightness. Webb observes as each planet crosses in front of the star, measuring the dip in light, catching the fingerprints of molecules in the thin ring of atmosphere. It's astronomy performed like whisper reading, the difference between light and shadow so small it would vanish to any other eye. A quirky tidbit comes to mind. One NASA scientist once joked that TRAPPIST-1 is the apartment complex of the galaxy, 7 neighbours sharing one efficient heat source. Another quipped that it's the only system in which you could probably send an interplanetary pizza delivery and still have it arrive warm. Yet humour aside, the truth is sobering. Red dwarfs like TRAPPIST-1 are prone to violent flares, sudden eruptions of radiation that can strip atmospheres and sterilise surfaces. Some of these worlds might be bare rock now, their air torn away long ago. Others might have developed thick, hazy atmospheres as armour. Webb's data is beginning to tell the difference, one spectral line at a time. You picture the scientists gathered as the first TRAPPIST-1 spectra appeared on their screens. They expected clear chemical signals, maybe water vapour, maybe carbon dioxide. Instead, they found almost nothing. The lines were flat, the signatures faint. One researcher described it as listening for a symphony and hearing silence. But silence is still information. It means those worlds may not have thick atmospheres at all, or that the star's radiation has sculpted them into barren stones. And yet, hope refuses to die. Each observation narrows the mystery, guiding future eyes toward the truth. Historians still argue whether red dwarfs are the universe's best homes for life or its most deceptive. Some claim their stability, burning for trillions of years, makes them ideal nurseries for slow-growing civilizations. Others counter that their volatility is lethal, that any early habitability would be erased by flares. Webb has become the judge in that argument, its instruments sensitive enough to see heat redistribution on these tiny planets, to measure how much starlight their surfaces reflect. Already, models are shifting. Some TRAPPIST worlds might indeed have atmospheres, thin, carbon-rich veils holding onto warmth just enough to keep water liquid. You glide over one of them now, TRAPPIST-1e, the most Earth-like of the 7. Beneath you stretches a dim copper ocean, or maybe a plain of frozen basalt. You can't be sure. The light is twilight no matter where you stand because the planet is tidally locked, one face forever staring at its star while the other sleeps in eternal night. Webb's sensors measure the contrast, mapping the temperature difference between day and night. It's strange to think that we can now detect weather on a world that our species will likely never touch. A fringe tidbit whispers through your thoughts. A few years before Webb launched, an artist painted all 7 TRAPPIST-1 planets as a speculative mural and sent a digital copy into deep space aboard a radio transmission. The file included one line of text. If you're already here, thank you for keeping the lights on. Somewhere, perhaps on one of these worlds, that message is still travelling, bouncing between particles, waiting for eyes that may never exist. You hover at the boundary between TRAPPIST-1e's day and night sides, watching faint auroras flicker along the magnetic edge. Webb can't see auroras directly, but it can infer their presence through atmospheric emission lines, little bursts of colour coded in infrared. They shimmer faintly, greenish and pink, like ghosts dancing on the Terminator line. You imagine standing there, feeling a wind that's half sunlight, half starlight. Maybe there's a thin haze, maybe a whisper of methane. The universe doesn't confirm or deny, it only suggests. Historians still argue whether Webb will ever find a definitive biosignature here, but even its silences feel profound. To learn that these worlds are barren isn't disappointment, it's calibration. Each non-detection refines our instruments, sharpens our questions, teaches us how to look better next time. That's the secret gift of science. Every no is a doorway to a more precise maybe. You drift farther back, taking in the entire system at once. 7 small worlds circling a quiet ember. Webb watches them relentlessly, orbit after orbit, recording faint whispers of light that will one day tell us whether life ever tried to bloom here. You think about how strange it is that hope can travel at the speed of light, and that it can last billions of years. The telescope's golden mirrors tilt slightly, catching one final glimmer from the red dwarf before moving on. Somewhere inside those hexagons, the reflection of those worlds lingers, and with it, humanity's longing for company. You whisper into the void, maybe to them, maybe to yourself. If you're out there, we're listening. You float away from the dim red ember of TRAPPIST-1, letting its tiny planets shrink to faint points of rust-coloured light. Webb's mirrors shift again, turning towards something even smaller, something that doesn't orbit a star at all. The telescope has been catching hints of molecules adrift between the stars, ancient chemical whispers older than any planet. You follow those signals through the dark, into clouds of gas and dust where starlight glows faintly like candlelight through fog. This is the universe's true laboratory, where chemistry turns into destiny. Out here, far from warmth or order, the raw ingredients of life assemble molecule by molecule. A mainstream historical fact hums in your mind. In 1983, astronomers using the infrared astronomical satellite first detected complex organic molecules, polycyclic aromatic hydrocarbons, in interstellar space. That discovery proved that carbon chemistry, the same foundation of biology on Earth, is common in the galaxy. Since then, telescopes and probes have identified formaldehyde, methanol, even amino acid precursors in cometary tails and molecular clouds. Webb, with its unprecedented sensitivity to mid-infrared light, can see those signatures in exquisite detail. Every molecule leaves a pattern of absorption lines, tiny fingerprints on the spectrum, and Webb reads them like a story written across billions of kilometers. You enter one of those nurseries now, a vast region of swirling gas called a nebula, its colors hidden from human eyes but blazing in infrared. Webb's instruments translate the light into shades of crimson and gold, each hue marking a different chemical: carbon monoxide, ammonia, sulfur dioxide, water ice. You drift through filaments of dust, watching them curl like smoke around invisible magnetic fields. Somewhere inside this fog, gravity will one day ignite a new star, and around that star, disks of material will clump into planets. But before all that, the chemistry must play its slow game: atoms meeting, joining, parting, trying again. A quirky tidbit drifts through memory. One of Webb's early spectral surveys focused on the Orion Nebula and discovered unexpected compounds, long carbon chains that, on Earth, would be considered pollutants. The researchers joked that the nebula smells like a burnt engine, if smell existed in space. Another observation revealed frozen carbon dioxide and methanol layered on dust grains, proof that the universe has been brewing cocktails of prebiotic chemistry since long before Earth was born. Somewhere a scientist held the first spectral plot and murmured, "So the recipe was written early." You think about that recipe as you glide deeper into the cloud. Each molecule here is a possibility, a step toward complexity. The temperature is only a few dozen degrees above absolute zero, but reactions still happen, slowly, patiently, over millions of years. When new stars ignite, their radiation will warm the dust and release those frozen molecules into space, scattering the ingredients of life like seeds on the solar wind. The process is messy and inefficient, yet inevitable. Given enough time, chemistry becomes biology. Historians still argue whether life began in places like this, inside interstellar ice grains that later rained down on young planets. Some scientists support the theory of panspermia, the idea that life's building blocks, or even microbes themselves, could have travelled between worlds aboard comets. Others insist that biology is too fragile for such journeys. But Webb's discoveries have reignited the debate. Its spectra show that the complex chemistry needed for life is not rare at all. It's woven into the very fabric of space. The cosmos, it seems, is predisposed toward creation. You drift near a comet forming on the edge of a new system, its surface glittering with frozen gases. Webb has observed similar bodies closer to home, detecting water vapor jets and organic compounds erupting from their nuclei as they warm. You can almost see the parallel. The same molecules Webb spots in deep space are the ones that likely soaked Earth's surface billions of years ago. The telescope, in its own way, is tracing ancestry, not of stars this time, but of cells. A small smile tugs at you as you remember a line from one of Webb's engineers. During an interview, she said, "We built a telescope to look for aliens, and it keeps sending us selfies." She meant that everything Webb finds, carbon, water, amino precursors, is a reflection of us. Even out here, in the coldest regions, the chemistry is familiar. The universe doesn't need to invent new ingredients for life. It just rearranges the same handful in endless combinations. You float past a denser knot of dust where light struggles to escape. Webb's instruments pierce that darkness, revealing streaks of ice-coated grains colliding gently. Somewhere in that microstorm, a molecule of glycine, the simplest amino acid, forms for the first time. It's nothing grand, just atoms dancing in the dark, but you can't help whispering a quiet, "hello." Perhaps, billions of years from now, that same molecule will find itself inside a cell on a planet not yet born. Maybe it will help something breathe. Historians still argue whether the boundary between chemistry and biology is distinct or a gradient, but Webb's data is blurring that line further with every spectrum. It shows us that the universe has been running experiments long before life appeared on Earth. Every comet, every dust grain, every nebula is a test tube, every photon a data point in the longest scientific study imaginable. You back away slowly, taking in the nebula as a whole. In visible light it would appear dark and ghostly, but through Webb's eyes, it burns with colour: reds for hydrogen, blues for dust, greens for organics. The view feels intimate, like peering into a womb. Somewhere within it, a new generation of stars and worlds is gestating, already infused with the same carbon and oxygen that now fill your lungs. The circle is complete. The chemistry of life is not a miracle, it's a habit of the cosmos. You breathe in, even though there's no air here, and imagine that every exhale you've ever taken sends those atoms back into the cycle. Perhaps one day, billions of years hence, they'll drift into another nebula, another world, another observer watching through another golden mirror. The thought warms you in the cold vacuum. Webb isn't just showing us where life could be, it's showing us that the universe has always been quietly preparing for it. You glide away from the molecular fog, carried by the gentle momentum of curiosity, until the dark opens into a glittering field of galaxies so dense it takes your breath. If breath still meant anything here. They crowd together, thousands upon thousands, some spiral, some elliptical, some just glowing smudges on a velvet canvas. The sight looks infinite, yet Webb captured it from a patch of sky no larger than a grain of sand held at arm's length. This is one of its deep field images, and floating here inside it feels like stepping into the most extravagant time capsule ever made. Every pinpoint of light is a world entire, each one older than memory, each one sending photons that have been travelling longer than life on Earth has existed. A mainstream historical fact flickers through your thoughts. The first deep field image came from the Hubble Space Telescope in 1995. Back then, Hubble stared for 10 days straight into what appeared to be an empty spot in Ursa Major, and the resulting photo revealed nearly 3,000 galaxies. It was a shock, a reminder that even in the emptiest patch of sky, the universe hides unimaginable abundance. Webb's version takes that revelation further. Its infrared eyes can see fainter and older light, stretching back to less than 300 million years after the Big Bang. In a single frame, it captured galaxies whose light began before our planet formed, their glow warped by time and gravity. You drift through the field as if swimming through a dream. The galaxies seem close enough to touch, though you know the distances between them are beyond imagining. Some appear as perfect spirals, serene and balanced. Others look like streaks or rings, distorted by gravitational lensing from invisible dark matter in front of them. You can almost feel the curvature of space bending around massive clusters, pulling the background light into delicate arcs. Webb's deep field data allows scientists to map that invisible mass, to weigh the unseen bones of the cosmos. You can sense it now, like a vast sculpture hidden inside the light. A quirky tidbit surfaces. One of Webb's early deep field exposures, SMACS 0723, was released to the public in July 2022, chosen as the telescope's debut image. When the first scientists saw it, some wept. One even said, "I feel like I'm falling into it." It was that sense of vertigo, the awareness that every pixel represented countless stars, perhaps countless lives. Even seasoned astronomers admitted goosebumps. For a week, the image circled the internet like a digital sunrise, a reminder that awe still had power in a noisy world. You float closer to one of the distant smudges, watching it sharpen into a spiral with a golden core. Its stars pulse faintly in infrared, their light stretched by the expansion of space. The redshift values Webb measured here, Z equals 10, Z equals 12, sound clinical on paper, but they represent epochs so remote that the human mind can't quite wrap around them. When that light began its journey, the Milky Way was only an idea waiting to happen. You could say you're looking at fossils made of photons. Historians still argue whether Webb's deep field observations mark a new era of cosmology, or the end of one. Some call it the completion of our cosmic picture, claiming that with Webb, we've finally seen back as far as light allows. Others insist it's merely the beginning, that hidden behind those faintest specks are still older, dimmer galaxies waiting to be uncovered by future telescopes. The debate itself is part of the beauty. Even when we see almost everything, we still suspect there's more. You turn slowly, taking in the whole field at once. The density of galaxies gives the illusion of texture, like sand on a cosmic beach. Each one has its own story, some still forming stars, others long dead, their light only now arriving. You imagine the photons brushing against Webb's detectors, then travelling again as data streams through space toward Earth. Somewhere, a computer converts those signals into colour, and somewhere else, a person gasps at the sight. It's easy to forget that you and those galaxies are connected by the same act of looking. A laugh slips out, soft, surprised. Humanity spent centuries painting the heavens with angels, dragons, gods. Now we've replaced myth with megapixels, but the wonder remains unchanged. The only difference is the medium. Webb has given the universe a self-portrait so intricate it almost feels like vanity. And yet, there's humility here too. Each tiny swirl of light reminds you that our solar system is less than a grain of dust in this grand expanse. You float toward a region where galaxies overlap like layers of lace. Webb's instruments have measured their composition, showing that some contain heavy elements, while others are still mostly hydrogen and helium. It's like watching a cosmic timeline condensed into one frame. Youth and old age side by side, separated by billions of years yet captured in a single glance. It makes you dizzy. It also makes you oddly peaceful. Time, it seems, has no urgency here. Everything that will ever happen has already begun, and everything that began still echoes in light. A fringe tidbit drifts in. To create some of these deep field mosaics, scientists used more than 1,000 separate exposures stitched together. The total integration time, the telescope's long, patient stare, can span days. They call it stacking, layering faint photons on top of one another until an image emerges from noise. The metaphor is irresistible. That's all knowledge is, really, stacking small bits of light until meaning takes shape. You realise that from this vantage point, the idea of isolation is impossible. Even in apparent emptiness, light is everywhere, travelling endlessly, weaving connection out of distance. You think of the people who will never see these galaxies in person, yet whose atoms were forged in the same ancient furnaces. The deep field isn't just a map, it's a family photo. You exhale, though there's no air here, and whisper into the endless glow, we are not apart from this. The galaxies shimmer faintly in agreement, their light still crossing space, still arriving, still speaking. Webb listens. You listen. And for a moment the universe feels very, very awake. You linger in the light of that infinite deep field, and slowly something unsettling begins to bloom beneath the ore. A whisper of confusion that mirrors the chatter of scientists back home. The more Webb reveals, the less the cosmos seems to follow the rules we thought it obeyed. Galaxies that are too massive, stars that are too old, structures that appear too early. It's as though the universe rushed through its adolescence, building entire civilizations of light before the script allowed. You float amid these impossible shapes, feeling that same cognitive vertigo that swept through astronomy when Webb's earliest images arrived. It's not that the telescope broke physics, it just showed how little of it we actually understand. A mainstream historical fact anchors the thought. In the early 20th century, Edwin Hubble's observations proved that the universe was expanding, leading to the Big Bang model that dominated cosmology for a century. That theory predicted a neat timeline. First light, then star formation, then galaxies, then large-scale structure. But Webb's data keeps rearranging the sequence. Galaxies that should have been formless blobs appear already mature and rotating. Star clusters sparkle with metals that shouldn't have had time to exist. Astronomers are jokingly calling this the cosmic speed run, as though the universe skipped levels to reach its endgame faster. You glide through one of those early galaxies now, its arms surprisingly defined. The stars here pulse with confidence, their chemistry rich and complex. You can feel the tension between what should be and what is. Webb has forced cosmologists back to their drawing boards, tweaking equations that once seemed settled. Some propose new physics. Perhaps dark matter interacts in ways we've never imagined, or maybe gravity behaved differently in the first billion years. Others wonder if the speed of cosmic expansion, the Hubble constant itself, might vary across time. It's as if Webb has turned the universe's clock into a Rorschach test. A quirky tidbit rises from the depths of memory. When the first batch of too early, too bright galaxies appeared, one research team labelled them with the acronym CEERS, short for Cosmic Evolution Early Release Science. Online, though, people began calling them the Impossible Galaxies. Someone even made a t-shirt that read "Webb broke the Big Bang." The humour masked the unease. Beneath the memes, scientists were genuinely rattled. For months, astrophysics Twitter was a controlled panic, a global conversation oscillating between "we need better calibration" and "we need new physics." You float deeper into this realm of paradoxes, feeling a quiet excitement build. It's not the dread of confusion, it's the thrill of frontier. Every time the universe defies expectation, it invites discovery. Historians still argue whether the Copernican revolution was humanity's greatest act of humility or its greatest existential shock. Maybe Webb's revelations are a modern version of that same lesson. We're still wrong about more than we're right, and that's a good thing. You watch light curl through space, redshifted beyond visible range, and realize that these photons are older than galaxies themselves. Some may have come from matter fluctuations just after the Big Bang, ripples in the cosmic microwave background that grew into the structures we now see. But Webb's images show those ripples crystallizing faster than theory predicts. The cosmos didn't meander into complexity, it sprinted. Maybe creation itself was impatient. Historians still argue whether the Big Bang's the whole story, or merely the opening act. A few fringe theorists whisper about cyclic models, universes expanding and contracting in endless succession, or multiverses where physical constants vary. Webb's data doesn't confirm those ideas, but it doesn't rule them out either. One scientist compared it to finding the universe's birth certificate and realizing it's in another language. The cosmos, as always, keeps its secrets bilingual. You hover before a spiral galaxy that glows faintly red, stretched by distance and time. Its light began when the universe was only a few 100 million years old, yet its shape rivals that of the Milky Way. Inside its arms, heavy elements sparkle: oxygen, silicon, iron. How could so much complexity exist so soon? Webb doesn't answer. It simply watches. And maybe that's enough. Not every mystery needs immediate translation. Some truths are meant to mature in silence. A fringe tidbit surfaces. In one of Webb's images, scientists noticed what might be a protocluster, a vast region containing dozens of young galaxies bound by gravity. They nicknamed it Pandora's Cluster, half in jest, half in warning. Studying it could open answers or unleash new contradictions. You like that metaphor? Every discovery in science is a kind of Pandora's box. We open it, expecting clarity, and out spills a universe of new questions. You think of the phrase scientists often use, tension in the data. It sounds mild, but it hides a storm. The Hubble tension, the discrepancy between different measurements of the universe's expansion rate, has only grown sharper under Webb's gaze. Depending on how we measure it, the universe might be younger or older than we thought. Somewhere between those interpretations lies a truth that might reshape cosmology itself. You drift backward, letting the galaxies blur into a mosaic of soft crimson points. The paradox begins to feel comforting. Maybe the universe's refusal to fit our equations isn't a flaw, it's a feature. If everything made sense, there'd be nothing left to seek. Webb is reminding us that reality is still stranger than theory, still playful, still proud of its secrets. You imagine the scientists back on Earth squinting at graphs, recalculating cosmic parameters with weary smiles. They know what you now feel in your bones, that certainty is overrated. The joy lies in the unravelling. And maybe, just maybe, Webb hasn't broken cosmology, it's saving it from complacency. You exhale into the dark, surrounded by galaxies that shouldn't exist yet but do, shining anyway. The universe, it seems, doesn't wait for permission, it just keeps creating. You linger among those paradoxical galaxies, letting the strange brightness fade behind you as you drift into quieter thoughts. It isn't just that Webb has upended timelines, it's that its discoveries have reignited an old, almost philosophical question. What is the universe really made of, and how stable are the laws that describe it? You can sense the restlessness echoing across the scientific world, the debates in dimly lit conference rooms and the midnight Slack messages between observatories. There's a new phrase floating around, the great cosmology reckoning, and out here in the endless dark you can almost hear it hum. A mainstream historical fact rises in your mind. For decades, the standard model of cosmology, the Lambda CDM model, has ruled supreme. It describes a universe made mostly of cold, dark matter and a mysterious force called dark energy, symbolized by the Greek letter lambda, the cosmological constant. This model has explained almost everything we see: the expansion of the cosmos, the distribution of galaxies, even the temperature ripples in the cosmic microwave background. But now, Webb's precise observations are revealing cracks in that once smooth equation. The expansion rate measured from nearby galaxies doesn't match the rate implied by ancient light. The universe seems to be both younger and older depending on which data set you trust. It's like having two clocks, both beautifully built, and watching them disagree by billions of years. You drift through a void between galaxy clusters, watching faint ripples of gravitational lensing shimmer across space. Those distortions are the fingerprints of dark matter, the scaffolding that holds everything in place. But Webb's maps show subtle differences from what theory predicts. Filaments more stretched, clumps more uneven, structures forming faster than expected. To a casual eye, it's all just beautiful noise. To cosmologists, it's the whisper of new physics. Maybe dark matter isn't perfectly cold. Maybe it interacts weakly with itself, or decays over time. Maybe it's not matter at all, but a sign that gravity changes at cosmic scales. Theories bloom like nebulae, too many to count, none yet bright enough to dominate. A quirky tidbit flickers through memory. One physicist joked that Webb's data had sent the universe to therapy. Everyone thought they knew who they were dealing with, a patient, predictable cosmos. But suddenly the old assumptions seem unreliable. During one panel discussion, a researcher quipped, "Dark energy was supposed to be boring." Now it's acting like it's got a personality. Laughter filled the room, though underneath it lingered unease. If the cosmological constant isn't constant, if dark energy is evolving or rippling or oscillating through time, then the entire future of the universe could look very different from what textbooks promise. Historians still argue whether these discrepancies mean the standard model is dying or just molting into a new form. Some caution patience. Webb's instruments are so sensitive that even minor calibration errors could mimic cosmic anomalies. Others insist the evidence is too consistent to dismiss. "Something is happening," one astrophysicist said simply, staring at a plot where theory and observation refuse to meet. "Either our physics is incomplete, or the universe is being mischievous." You smile at that, because out here, amid all this shimmering uncertainty, mischievous feels like the right word. You turn toward a patch of faint red galaxies glowing like embers. They seem ordinary until you notice the light bending around them more strongly than it should. That's the hand of dark energy, the force that stretches the fabric of space itself, accelerating everything outward. You can almost feel the push, a gentle pressure under your feet that never stops. The irony isn't lost on you. The universe is expanding faster and faster, while our understanding of it struggles to keep up. Webb's data has made that acceleration more precise, but also more mysterious. It's like measuring the wind perfectly and still not knowing what's blowing. A fringe tidbit surfaces, half rumour, half poetry. During a private symposium, a cosmologist supposedly compared dark energy to the universe's memory of the Big Bang. She described it as a leftover vibration from creation itself, still resonating, still driving everything apart. Some rolled their eyes, others scribbled notes. It's not a testable theory, but it captures something human, the need to name the unknowable. Science, at its edges, always slips into metaphor. You drift through another cluster, its heart pulsing with the light of thousands of galaxies. Each one is both proof and puzzle. Webb's instruments detect subtle differences in colour and brightness that help chart the rate of expansion over time. The result is maddening. The data fits perfectly within itself but doesn't line up with older measurements from the cosmic microwave background. It's as if the universe is rewriting its autobiography while we're still reading it. Maybe it isn't lying, just evolving in ways we haven't yet imagined. Historians still argue whether this will become another paradigm shift like those triggered by Copernicus or Einstein. Some caution against the romance of revolution, warning that the anomaly might fade with better statistics. Others see in it the dawn of a new physics, a reality where constants aren't constant, where space-time is alive, dynamic, responsive. The tension between those views feels electric, and out here you can almost see it sparking between galaxies. You watch a wave of light pass through the void, stretched by expansion until it turns invisible. Somewhere in that fading glow is the key to everything, the density of dark energy, the fate of the cosmos. Will it keep accelerating forever, tearing galaxies apart until even atoms drift alone? Or will it slow, pause, and collapse into another beginning? Webb can't answer that yet, but it's collecting the evidence one photon at a time. The telescope doesn't speculate. It observes, and in its patience there's comfort. You exhale, the stars blurring into a luminous haze around you. Maybe this reckoning isn't a crisis, but a renewal. The universe isn't breaking our models to be cruel. It's nudging us forward, daring us to think bigger. You remember something an astronomer said after seeing Webb's first dataset. It's like being handed the universe's diary, and half the pages are still blank. You glance at those pages now, glowing faintly in infrared, and whisper the only sensible response, keep writing. You drift in the silence between galaxies, letting the hum of cosmic reckoning fade into something more intimate. The data, the models, the debates, all dissolve until what's left is light. Pure, patient light. For all its equations and mysteries, the James Webb Space Telescope is, at heart, a collector of beauty, a mirror turned toward the infinite that somehow reflects us back. You float beside it again now, its gold panels gleaming like the petals of a frozen sunflower. Each one catches a fragment of starlight that left its source before humanity existed, before even the concept of existence meant anything. It's impossible not to feel small here, but it's also impossible not to feel included. The telescope isn't looking away from us. It's looking through us, seeing the part of the universe that dreamed itself awake. A mainstream historical fact threads softly through your thoughts. Webb wasn't the first telescope to make people cry, but it might be the first to make so many do it at once. When NASA unveiled its first images in July 2022, the reactions weren't just scientific, they were emotional. People described it as a spiritual moment, a shared pause that transcended borders and languages. Presidents, poets, engineers, children. Everyone seemed to stop scrolling for one heartbeat of collective awe. You remember those pictures now, the phantom shapes of distant galaxies, the Carina Nebula glowing like a stained glass window, the Southern Ring Nebula with its double star gleaming like a cosmic eye. For a rare moment, humanity looked in the same direction and remembered how to wonder. You think about the people behind the telescope, the thousands of engineers, scientists, programmers, and dreamers who spent decades assembling this golden time machine. A quirky tidbit surfaces. One of Webb's lead optical engineers, Lee Feinberg, once admitted he whispered "thank you" to each mirror segment before launch. Another carried a small stuffed penguin to every integration meeting, calling it the project's mascot of persistence. These tiny rituals, half superstition, half affection, became part of the telescope's DNA. Maybe that's why Webb feels so alive, like it's more than machinery. It carries fingerprints, laughter, and caffeine stains from a generation of people who refuse to give up on wonder. You imagine the control room on launch day, December 25, 2021. While the world celebrated or slept, hundreds of nervous faces stared at screens. For 30 days, as Webb unfolded piece by piece on its journey to the L2 point, they barely breathed. Every hinge, every motor, every cable had to perform flawlessly. One missed click, one frozen gear, and the dream would end. But the miracle unfolded perfectly. Someone later said, "It was like watching origami bloom in space." You think about that now, floating above the fully open telescope, and realize how human the act of unfolding is. Vulnerable, deliberate, full of faith. Historians still argue whether Webb's triumph marks the pinnacle of the space age or just its beginning. Some see it as a final monument to the 20th century's optimism, a telescope so advanced it borders on art. Others see it as the foundation of a new era, one where machines built for awe become extensions of human empathy. When you gaze at its gleaming mirrors, it's easy to believe both. The line between art and science blurs here, just as the line between observation and reverence does. You drift closer, tracing your reflection across the golden hexagons. The panels shimmer faintly, fractured into honeycomb geometry. In your warped reflection, you see humanity itself, flawed, bright, hopeful. You think of how we build these colossal tools not just to measure the cosmos, but to measure ourselves against it. Webb's images aren't just data points, they're mirrors that say, this is what curiosity looks like when it grows up. A fringe tidbit whispers through memory. During one of the first image processing sessions, an artist on the NASA team quietly added a fraction more color contrast to a nebula photo. not to fake the science, but to make the emotional truth visible. When asked later why, she said, "Because the universe is louder than our eyes can hear." That phrase has followed you ever since. You can almost hear that loudness now. Not sound, but intensity, a symphony played in radiation and distance. You look beyond Webb into the sea of stars it watches, realizing how personal this all feels. Every image it sends home becomes a shared dream, a reminder that our small blue world belongs to something vast and ancient. You picture the countless people scrolling through Webb's photos on their phones, squinting at galaxies billions of light years away between morning emails and evening commutes. For a second, every one of them is a cosmologist, a poet, a participant in infinity. Historians still argue whether our fascination with the stars is instinct or inheritance. Maybe it's both. The same carbon atoms forged in the first stars now build our neurons, and those neurons spark curiosity. Webb isn't discovering the universe so much as remembering it. It's a machine built by stardust to understand stardust. And that realization, that recursive elegance, makes you smile. You drift a little farther out, giving the telescope its space. Its sunshield glows silver in the distant light, whisper thin yet capable of blocking the heat of an entire star. You imagine the signals flowing through its instruments, infrared photons turned into bits of data, bits turned into pictures, pictures turned into meaning. From that chain of translation comes connection. Webb sees the earliest galaxies, and in doing so, it gives us perspective on our own beginnings. You feel the echo of Carl Sagan's old truth. We are a way for the cosmos to know itself. And maybe that's the quiet miracle. Webb isn't looking outward or inward. It's collapsing that difference altogether. Each photon it collects is both a memory and a prophecy, light from the past illuminating the future. The telescope hums softly, patient, unhurried, content to watch eternity unfold. You close your eyes and listen to it, not the mechanics, but the meaning. It's the sound of human curiosity singing in tune with the universe. You drift beyond Webb now, the golden telescope shrinking to a faint glimmer in the starlit dark. It remains behind you like a sentinel, quietly collecting the oldest light in existence, while your thoughts stretch toward what comes next. Humanity's eyes have never lingered in one place for long. Even as Webb continues to rewrite cosmic history, plans are already forming for the next generation of instruments. Machines that will make even this grand miracle seem like a prototype. The future of vision, it seems, is infinite, and you're floating at the edge of that horizon. A mainstream historical fact glows in your memory. Every great telescope has had its heir. Hubble gave birth to Webb. Webb, in turn, will give rise to the Habitable Worlds Observatory, a mission NASA hopes to launch in the 2040s. It's designed to look not just backward in time, but outward toward life, to study Earth-like planets around Sun-like stars, searching for signs of oxygen, water, and maybe something stranger. If Webb is a time machine, its successor will be a detective. You can already imagine it hovering in the dark, its mirrors even larger, its sensors tuned to catch the faintest breath of biology across light years. Humanity is building telescopes the way evolution builds eyes, each generation sharper, more daring, more aware of its own blindness. You glide through the void, watching faint shapes coalesce in your imagination. Future missions flicker before you like ghosts of ambition. The Origin Space Telescope, designed to probe the chemistry of star and planet formation with even colder detectors. The Louvoir concept, with a mirror twice the size of Webb's, and a coronagraph capable of blocking a star's glare to photograph actual Earth analogues. And beyond even those, rumours of telescopes built not in orbit but on the moon's far side. Vast arrays shielded from Earth's noise, listening to the universe in radio frequencies older than light itself. The idea feels impossible, but so did Webb once. Every dream starts as noise before it becomes a signal. A quirky tidbit surfaces. One engineer described the next generation of observatories as building telescopes for photons that don't even exist yet. She meant it as a joke, but the more you think about it, the truer it feels. By the time those missions fly, the light they'll catch will have been travelling for billions of years. Photons born before humans had words for curiosity, arriving just in time to meet instruments we haven't built yet. The coordination between cause and discovery is absurdly poetic, like the universe scheduling appointments with itself. You turn your gaze back toward Earth, far away now but still gleaming faintly blue. Somewhere on that small sphere, thousands of people are already sketching designs, running simulations, debating the future of cosmic exploration. You can almost hear them, scientists arguing over budgets, engineers whispering to models, artists painting concept art that will one day inspire new generations. Each blueprint is an act of faith, a promise that even if we never reach the edge of the universe, we'll keep trying. Historians still argue whether the next leap in cosmology will come from bigger telescopes or smarter algorithms. Some believe that artificial intelligence, trained on Webb's vast datasets, will find patterns no human mind could recognize. Others believe that nothing replaces wonder, that intuition, not computation, remains the engine of discovery. Maybe both are true. Maybe the next scientist to redefine our understanding of existence won't be human at all, but a program quietly connecting dots in the background, seeing what we cannot. You can almost picture Webb's data streams feeding into those digital minds, the machine learning from a machine, teacher and student separated by starlight. You float onward, imagining the decades ahead, the habitable world's observatory unfurling its mirrors like a silver flower, the LUVOIR's giant disk gleaming like a second sun, the lunar observatory whispering through the radio silence of a cratered plain. Perhaps these instruments will detect something definitive, a spectral line showing methane and oxygen together, the fingerprint of life. Or maybe they'll find nothing but beautiful emptiness, and even that will be enough. After all, to look is to honour existence, even when it looks back with silence. A fringe tidbit shimmers through your mind. A small private company has already proposed building telescopes made of liquid, spinning mirrors formed from molten metal in zero gravity. The idea sounds wild, but so did gold-coated hexagons once. Innovation, it seems, always begins as madness. One engineer reportedly said, "We're trying to give the universe a better mirror." The phrase lingers with you because it feels true on a deeper level. Each telescope isn't just about seeing further, it's about refining reflection itself. You glance ahead, where time itself seems to thin. Maybe one day we'll build instruments that detect not just light or gravity, but memory, tools that read the quantum scars of creation, the leftover vibration of beginnings. Maybe we'll find a way to see before the Big Bang, to witness the unseeable. Humanity's trajectory, after all, has always pointed toward impossible. Webb proved that the limit of vision isn't technology, it's imagination. Historians still argue whether our appetite for discovery will outlast us. Some say curiosity is our evolutionary accident, others call it our salvation. But floating here, watching the faint glow of Earth against the infinite dark, you can't help but think it's our most human instinct. Every generation inherits both the questions and the tools to ask them louder. Webb is proof of that lineage, a golden reminder that looking outward is also a way of looking forward. You take one last look at the telescope behind you, its panels still catching light that began before language. It hums softly, steady, content, an emblem of patience in a restless species. The thought soothes you. Even if humanity never solves the universe's riddles, at least we'll have asked them beautifully. Somewhere, another telescope will rise, another mirror will bloom, another set of eyes will open. You smile, weightless in the endless night, and whisper, "The future is watching too." You begin to drift homeward through the same star-laced darkness that has carried you for what feels like eternity. The James Webb Space Telescope shrinks behind you, its golden mirrors dimming to a mote of reflected sunlight. You can feel the warmth of Earth calling from far away, a faint gravitational tug that feels less like physics and more like belonging. All that light Webb has gathered, all those ancient photons now stream quietly toward humanity's waiting eyes. They will become images, ideas, papers, arguments, inspiration. The telescope will keep watching, but for you, it's time to return beneath the same starlight that began this journey. You descend through layers of distance that don't have names, passing galaxies, dust lanes, and the faint echo of radiation left from creation's first fire. Every wave of light that brushes past you carries stories older than memory, and yet somehow they all feel personal. You've spent so long travelling backward in time that forward suddenly feels unfamiliar. The realization hits softly. Everything you've seen, the galaxies, the nebulae, the collisions and impossibilities, still exists, still glows, still sings. The universe doesn't end at the edge of observation, it extends into the imagination of those who dare to look. A mainstream historical fact drifts in as you fall toward home. Earth's night skies have always guided civilization. Ancient Egyptians aligned pyramids to Orion's belt. Polynesian voyagers steered by starlight. Galileo's small brass telescope opened the modern heavens. The James Webb is simply the latest chapter in that lineage, another tool for the same ancient impulse. Our ancestors painted constellations on cave walls. We now paint them with photons on digital sensors. The medium changes, the longing doesn't. You picture the telescope continuing its endless ballet at L2, 1.5 million kilometers from the planet that built it. Its antenna glows faintly as it sends down data, streams of binary rain that scientists will translate into color and structure. Those files will move through fiber optic cables, across continents, into labs, schools, and living rooms. Someone will stare at a new deep field image for the first time and feel the same jolt of wonder you felt out here. In that instant, the loop will close, the universe observing itself again through human eyes. A quirky tidbit rises to mind. Webb's engineers included a small plaque on the telescope engraved with their names, and the phrase per aspera ad astra, through hardships to the stars. They hid it near the base of the sunshield, where no one will ever see it except perhaps a future civilization that finds the telescope drifting long after our species is gone. The idea that our signature floats through space, quietly orbiting the sun, feels strangely comforting. Even if we vanish, our curiosity endures as hardware. You pass through the lunar orbit now, seeing the moon's pale face glowing below. Its surface seems peaceful, but you know it's destined to host new observatories someday. Radio arrays stretching across its far side, telescopes free from Earth's noise. The line between exploration and habitation is blurring. Webb may have opened the universe, but others will step through the doorway. Humanity's gaze is evolving from distant to immersive. We are learning not only to observe the cosmos, but to live alongside it. Historians still argue whether this hunger to look outward is bravery or denial. Some claim we seek the stars to escape our flaws, others say it's how we confront them. You suspect both are true. In the mirror of the universe, we see our capacity for both destruction and creation magnified. Webb's gold mirrors show galaxies forming and dying, but they also show endurance, light that survives everything. Perhaps that's the reflection we need most. You cross into the thin blue shell of Earth's atmosphere. The light refracts around you, softening from cosmic crimson to sky blue. The noise returns. Wind, radio chatter, heartbeat. The stars fade behind daylight, but their memory lingers. You feel heavier now, but in a good way. The weight of knowing, of having seen. Below, continents shimmer with city lights, tiny constellations built by human hands. From this height, it's impossible to tell where nature ends and curiosity begins. You think of Webb again, still up there, still listening. Its mirrors will age, its sensors will dim. One day, its orbit will drift, and the universe will quietly reclaim it. But the knowledge it captured will persist, encoded in servers, minds, and imaginations. Future children will learn that in the early 21st century, humans built a golden eye that looked 13.5 billion years into the past and found not emptiness, but abundance. And maybe one of those children will glance up at night and whisper the same thought you're having now. We are part of that light. You hover a moment longer above the planet, the curve of the horizon glowing like a promise. The hum of Webb's instruments seems to echo through the atmosphere, a lullaby of data and destiny. You close your eyes, letting that sound fade into your breathing. The journey ends not with answers, but with awe, the oldest emotion, the truest one. The telescope will keep watching, the universe will keep expanding, and you, small and bright and temporary, will keep wondering. Your descent through the dark slows until motion itself seems to hush. The stars soften, their edges blurring like candle flames behind glass. You can still sense Webb far above, its patient mirrors turned outward, but its hum has grown faint, less a sound than a memory. The air around you thickens, warm with the comfort of home. Every breath feels heavy with starlight. Let the pace ease now. Let the sentences stretch the way twilight does when day ends gently. You have wandered across billions of years tonight, through creation and collapse, through questions that may never finish being asked. Yet somehow, here at the edge of sleep, All that immensity folds neatly inside your chest. The galaxies feel small enough to hold. Think of the first light Webb ever captured, the faint trembling photons arriving after their long pilgrimage. Think of how quietly they landed. No fireworks, no thunder, just light meeting gold. That's how discovery happens, always. Not in noise, but in stillness. You are that stillness now. The cosmos hums around you, and for once it doesn't demand explanation. It just exists, endless, intricate, and kind. The same atoms that once flared in those early stars now cool against your skin. You've been everywhere tonight, and you are still here. Breathe once more. The dark outside your window is no longer empty, it's filled with memory. Let your thoughts drift like satellites into that calm expanse. The universe is watching over itself, and you are part of its gaze. Sleep well beneath ancient light.